All right, today we're doing something a little different. We're going to crack open the source code of Bitcoin to uncover a hidden language, one that, believe it or not, has a whole lot in common with the code of life itself. Let's dive in. It's a pretty wild question, isn't it? I mean, on one side, you've got biology. It's messy, it's organic, it's been evolving for billions of years. And on the other, you have cryptography. It's precise, it's mathematical, it's pure digital logic. But as you're about to see, the parallels here are way deeper than you might think. So, before we can really wrap our heads around the digital side of things, we've got to start with the original source code, life. Let's do a quick refresher on some high school biology. At the very heart of every living thing, you have DNA. You can think of it as the ultimate source code, right? It's this massive instruction manual for how to build an organism, and it's written in a surprisingly simple four-letter alphabet: A, C, T, and G. These are the absolute fundamental building blocks of life. Okay, so if DNA is the entire library, then a gene is like a single recipe from one of the books. It's a specific sequence of those DNA letters that gives a cell a complete, specific instruction, like, hey, build this particular protein. Each gene is a self-contained command. So, how does a cell manage to store this incredibly long, ridiculously complex string of code? Well, it uses this absolutely brilliant packaging system. The DNA chain wraps itself around these proteins called histones, and then it coils up again and again, compressing itself into that dense little structure we all recognize as a chromosome. It's basically nature's own masterpiece of data compression. All right, you with me? With those biological basics covered, let's switch gears and see how this very same logic shows up in the digital world of Bitcoin. So just like all life is built from those four basic letters, Bitcoin's programming language, which is called Bitcoin script, is put together from a limited set of fundamental building blocks. You can think of them as its digital atoms, and they're called opcodes. And we can even organize these digital atoms kind of like a periodic table of elements. There are different families of opcodes, and each one has a very specific job. You've got codes for doing math, like op-add, you've got codes for security and cryptography, and others that just manage data. These are the simple, basic elements of Bitcoin's language. And you guessed it, when you string these digital atoms together in a specific sequence, you create a digital gene, which in the Bitcoin world we call a script. What you're looking at right here is actually the most common script in all of Bitcoin. It's a precise sequence of opcodes that acts as a digital lock on money, spelling out the exact conditions someone has to meet to spend it. It's a complete instruction, just like a gene. So, to put it simply, Bitcoin script is this very straightforward programming language where instructions just get processed one by one, like checking off items on a list. Its entire purpose is to run these digital genes to prove that a transaction is valid before the rest of the network will accept it. Now we get to the most interesting and kind of peculiar feature of this entire digital language. It's something that, at first glance, seems like it would be a major flaw. Okay, here's the key difference. Most programming languages you've ever heard of use things called loops, commands that let a program repeat a task over and over, sometimes forever. Bitcoin script, it was designed without infinite loops, on purpose. Every single script is guaranteed to run and then stop. It has to finish. But this isn't a weakness. It's a core design principle. One source describes it perfectly, calling it a system composed not for infinite loops, but for finite, expansive sequences. It's like a piece of music that's designed to have a final note. And why is that so important? Well, it's a brilliant way to solve a huge problem in computer science known as the halting problem. By guaranteeing that every script must finish, you make it impossible for a single transaction, whether it's buggy or outright malicious, to get stuck in an infinite loop and grind the entire global network to a halt. It's a profound security feature that ensures the whole system is predictable. So, if every script has to end, how in the world does Bitcoin handle anything complex? This is where that analogy to life gets really, really clever. This is the big paradox, right? We have this language that is intentionally limited. It can't run forever inside of one transaction. But we also know that Bitcoin can support some pretty complex applications. So, how does it do it? The solution is just fantastic. The loop doesn't happen inside a single script. It happens between scripts. One transaction runs its finite program, and then it passes its result, its state, to the next transaction in the chain. It's the digital version of genetic information getting passed down from a parent to a child. Here's how that works, step by step. Transaction 1 runs its script, and it finishes. Its output can hold not just money, but also data, the new state of a program. Transaction 2 then grabs that output, uses it as its own input, runs its script, and then creates a new output for transaction 3 to pick up, and so on and so on. By chaining transactions together, you can build a process that is effectively limitless, but it's made up of these small, safe, predictable steps. So let's zoom all the way out now and put all of these pieces together. What we're looking at is something much bigger than just a payment system. We're looking at a complete digital genetic system. Here it is, the whole analogy in one place. The opcodes are the nucleotides, the basic chemical letters. The scripts are the genes, giving the instructions. The chaining of transactions, well, that's replication, passing those instructions through time. And the entire blockchain itself? That's the collective genome of the network, a complete, unchangeable, and verifiable record of its entire computational life. And if we want to take it just one step further, you can think of each new block that gets added to the chain as a kind of cell division, a moment of digital mitosis. The current state of the whole system is faithfully copied and passed forward, creating the next generation of the network. And all of this leaves us with one final, pretty fascinating question to think about. If the blockchain really is a digital genome, a new form of life that can learn and evolve through computation, what is it ultimately going to become? Now that is something to chew on.